Hello, this is Nitin Dahad with EE Times, and I'm here at the Arm Everywhere conference in San Francisco. Big launch today. Arm launched their AGI CPU, and I'm here with Ravi Subramanian of Synopsys. Hello, Ravi.
Hi, Nitin. Great to see you again.
Yeah, I mean, it's always wonderful to talk to you, and you had an interesting few weeks with Synopsys Converge and GTC, and now this. It's all happening here in this industry, isn't it?
It's a busy time in the AI era.
Yeah, and like the big announcement today, you've had, you as in Synopsys has had an instrumental role in helping Arm develop the chip, and it's quite a complex chip. So just tell us a little bit about the story here.
Sure. The AGI CPU is one of the most complex CPUs ever built. And
Chiplet-based.
Chiplet-based. And the complexity and the time frame in which it was achieved is really remarkable, and hats off, kudos to the ARM team on executing that. Our role in that chip was really to enable ARM's engineering to be able to achieve the outstanding results they did in the time frame they did. And that's really coming in three places. The first one is Synopsys is a leading provider of interface IP. And together with the computing subsystem that ARM built, ARM leveraged Synopsys interface IP, including the PCIe Gen 6 interfaces, and which was silicon proven on TSMC's N2 process, N3 process. So ARM could count on certainty with that. So that really dramatically reduces the time of building the chip by taking interface IP together with what ARM created to create the final chip. Second, ARM leveraged a large number of Synopsys EDA tools, RTL verification, all the way through IC validator, to actually sign off the chip prior to going to TSMC and signing off with confidence. And third, ARM leveraged the ZeBu emulation platform to emulate the full chip before it actually went to tape out. They were able to do both functional verification and system validation with workloads running on the chip, which gives them much more confidence that as the chip comes back and their customers are running workloads, the chip is performant to its actual specs.
Now, I mean, this basically, from what I've understood from talking to you, is kind of validation of your own whole design flow. Right through to the chip emulation.
Indeed.
And what I'm wondering is, like, you've like announced various parts of this through the last 2-3 years.
Yes.
I'm guessing, is this more complex than the automotive stuff you've been doing? I mean, you said it's quite a complex chip, and I don't know how many cores. I mean, were quoted on this chip, but it's equivalent to some of the stuff NVIDIA is doing, isn't it?
Absolutely. So, in terms of complexity, what we're seeing is the rate at which AI compute is growing. It's demanding a phenomenal amount of computer architecture, both innovation but also just complexity. In terms of how does this compare with what's in automotive, I would say it's different in that here we're already moving into the agentic era, and this is now the first real. What do you need? First real chip on what do you need for computing for agentic? In the automotive side, we're seeing the first introduction of generative AI for the IVI and ADAS application. And the complexity of that, I would say, is nowhere near the complexity of this from a sheer billions of transistors perspective. But in terms of the system complexity, right, there's a whole bunch of things regarding the automotive or autonomous environment these chips need to operate in, which are a completely different dimension of the problem.
I mean, I'm not comparing like with like, but I was just thinking in terms of the complexity.
Yes, indeed.
And then, I mean, it's quite interesting because for you, Synopsys, I mean, what does that mean for your other customers? I mean, you can tell them, like, okay, here's something we've done, or, I mean, what's the big takeaway from here?
The biggest takeaway is, for the most complex chips that are being built in any domain, AI is coming into computing everywhere. So these chips become more and more complex. And the surest path to silicon success is really leveraging the right IP portfolio, so you can really focus on what you build versus what you actually assemble and reduce the time it takes to build it, and then confidently get to tape out with silicon-proven tools, and leverage emulation as much as possible, because you can successfully emulate the largest chips and actually have software development starting much earlier in the process. And for any domain, not only in the data center, but in automotive or industrial or aerospace,
Yeah.
all those really come to bore. So you can really count on Synopsys for getting successful first silicon out the door.
And Rene presented a roadmap. There's going to be AGI chip 2, chip 3. Obviously, this you worked on for 1.5, 2 years with them. So you're already working with them on the next one, I guess. And you can't say, but I'm kind of trying to tease it out.
Sure. I think one of the greatest drivers for innovation at Synopsys is the toughest customers giving us the toughest problems to drive the advancement in the capabilities, both the tools, the IP, the emulation. So customers like Arm have been working with Synopsys for over 22 years. And driving
Only that long? I thought it was longer.
Perhaps longer, maybe, but what they have done is they're one of the customers that really push us.
Yeah.
And innovation in our field is really driven by customers that have big, hairy goals. And what Mohammed shared today, I mean, just the sheer engineering complexity of that.
Yeah.
You could say it broke a few things inside Synopsys in order for us to advance the state of the art.
I mean, that's how innovation happens.
Exactly.
Isn't it? But,
Exactly.
Let's just take 2 minutes, because I haven't spoken to you since Synopsys Converge, which was 2 weeks ago. How was that for you? I know you did a fireside chat with my colleague Sally, and
Yes.
well, what are the key takeaways for you from that?
The key takeaways really are, for us, it was our first event together with ANSYS.
Yeah.
And
I saw Preet here earlier.
Yes, indeed. And so, as I like to say, it brings together everything from the atoms to the orbital of planets.
Right.
The scale of systemic complexity that are brought together. So it was really exciting for me to see the ANSYS community of engineers. They represent 18,000 customers all over the world, and the Synopsys community of engineers, about 2,000 semiconductor companies primarily.
Yeah.
And bringing them together and looking at more and more problems today absolutely require a system thinking where you're thinking not only about the electronics, but the world electronics is living in. And how do you actually solve that problem by co-design or really co-engineering in different domains? And that was the main theme. It was the first time it was ever a theme at Synopsys for that.
Yeah.
But it was also a chance where we would have Meta, Boeing, and Mercedes-Benz on a panel talking about systems and silicon, which I think is a really unique thing in history right now.
I love that. I mean, I watched a lot of it, but I missed that one, so I've got to go and catch that. But Ravi, thank you very much.
Great. Thank you, Nitin. Great to see you.